So here we have Parkside's new prodigial son, the PPSK 40, the integrated compressor version of the PPK 40 plasma cutter. It's rated up to 40 amps, comes with just a couple of accessories, a couple of extra electrodes, some burner sleeves, an extra compressor hose for the optional compressor attachment if you don't want to use the internal compressor. The ground clamp here takes the standard DINSA 25 plug. In the middle we have our standard two-prong control socket, and for our plasma cutter hose we have an M16 by 1.5 millimeter thread to connect the head. So let's see what's under the hood under this case. For that, we're just going to remove 2 screws from the top, 7 from each side, and another 6 from this front plastic panel. That will allow us to get inside this bad boy and see what makes it tick. So now that we are inside the case of the PPSK 40, here we have our main PCB that's doing all the voltage conversion. So one quick warning first, here we have some large mains capacitors and also some high voltage capacitors. These will carry a charge if the device has been plugged in recently. So if you're going to be doing any maintenance inside here, make sure those are discharged. So just to improve our visibility, we're going to remove this plastic cover here that's hiding the main control section here. So on our input we have our switch feeding this top PCB. Here we just have some filtering going on, going to the relay that is handling turning on the compressor. The compressor here is fed directly by rectified mains through this full bridge converter. So it is basically a 300 volt DC compressor hidden behind the main board in this metal can. On the forward panel, we just have our compressor switch and our control board that we can easily pull off. So the control board itself carries all of the microcontrollers for the voltage conversion. So we just have our potentiometer for current selection and our indicator LEDs there. So moving on, the power from our switch goes into this lower board here, where all the magic of turning the high voltage mains to high current, low voltage plasma cutting output happens. So here we have just a safety relay controlling the mains power input here, and then we have our setup of 4 IGBTs. In this case, these are SGT40 N60 NPFDs, quite a mouthful. Anyways, since we have 4 mounted here, we have a full bridge forward converter that just gives us high efficiency, and as they are IGBTs, we should have better lifetime than if it was using standard MOSFETs. So having the full bridge, it basically switches the rectified mains from another full bridge rectifier in here, charging these 2 big mains capacitors. They switch the rectified mains through this toroidal transformer. It then goes through 4 diodes forming another full bridge rectifier on the output. These are also fairly massive KBF60 F60Es. So the IGBTs themselves are capable of 40 amps at 600 volts, and our diodes on the bottom here are capable of 600 volts, 60 amps. So fairly well matched to the maximum 40 amp output of the plasma cutter. That rectified current, low voltage now, passes through an inductor, and then it has this interesting area here. You might recognize this as a high voltage transformer that actually induces the starting pilot arc current on your plasma cutting torch head. With this flyback transformer here, we're actually inducing the high voltage on the output of the plasma cutter, and that's active at the beginning of you pulling the trigger, generating the high voltage arc that enables the plasma cutting to start. Here are the corresponding high voltage capacitors, and above it, as you'll see in this short clip, we have the spark gap that actually limits the maximum voltage that can be attained from this transformer, basically to limit the voltage that is going to be coupled to the main output. So once the voltage achieves a high level, it actually jumps the spark gap and just limits the voltage that's able to be induced through this transformer. So all in all, on the front, we have some additional fan inputs. This is for the main case fan. This wire goes to the smaller fan on the compressor. This wire is to the compressor switch at the front. This goes to the temperature bimetal switch, 75 degrees centigrade on this one here, just making sure those IGBTs aren't cooking themselves. This wire here controls the compressor relay, and here we just have the wiring coming in from the front panel socket to the trigger. And the outputs here, this is the positive plasma cutting output, this here is the negative. So the two case fans that we have here, the larger left side fan that might be a candidate for replacement just due to noise and quality, is a 24 volt, I believe 120 millimeter width fan, 38 millimeters deep, and the smaller fan hiding behind here for the compressor, again 24 volts, 70 millimeters with 25 millimeters depth. You'll see those numbers on the screen. So what we have here for pneumatics, we have these three hoses here. This is obviously the output to the plasma head. Here we have the optional input on this three-way T to the external compressor that is possible to add if you don't want to use the noisy compressor inside. You can close that off. Then the pressurized air is fed from the internal compressor into this T and directly to the output. So all in all, the design of this board, certainly high quality, using these IGBTs instead of MOSFETs, very beefy full bridge rectifying diodes on the output, beefy transformer. We have 8 American wire gauge outputs on these fairly short wires to the output. Those again might be a candidate for some upgrades. If you really want to get this to maximum performance, you exchange the fans, you put in some, let's say 10 gauge or 6 gauge wires on here, and you should be getting the maximum performance this thing is capable of. Here we just have some local low voltage to power the fans and to power the board, a bit of current sensing, and this transformer here acts as a driver for the IGBTs that basically form an H bridge that can drive our transformer both ways, basically just getting more efficiency out of the system. So let's spin this thing around and have a look at the dinky compressor they've included on here. So now to the compressor side, you can see it is fully encased in this metal shield. We have 2 grommet holes here giving us the air hose and the power. So if we monkey around with this very sharp metal casement, we should be able to get this thing released. So just bear with me here for a second while I remove this. Pull these wires off through this hole here, release the quick release hose connector, and that should give us some level of access to the compressor. So just route these hoses and wires out, and you can see we're just left with the case fan on this metal casement. So inside here you can see I've already taken it apart slightly for easier presentation. We have our dinky little compressor. As I said, it's being fed with rectified mains DC, so a fairly odd voltage for a sort of double-headed compressor here with our DC motor in the middle. We have these cast aluminum cylinders here that are just connected, unfortunately, with these wood screws directly into plastic, which forms the body of the compressor. We can pull these screws out. Of course, there would be 4 holding the whole head onto this system. The outer body of the compressor, so all this plastic here, I believe is something like a PA66 glass fiber reinforced 30%. So it should be fairly durable, but of course it would have been nicer to have this slightly more sturdy and solid. So I'm just going to pull off the quick release hose on top here, and we can see the compressor. On the bottom it's retained with these sort of rubber feet that should reduce noise and vibration, but the compressor itself comes apart just with those 4 wood screws. We can open up the top that shows us the top chambers and valves. We have our reed valves on the top of these, I guess, cylinder heads here, just some thin strips of spring steel. If we move this to the side, you can see the cylinder head itself. So we just have this cast aluminum with some kind of Teflon gasket or piston ring in here. Unfortunately, the pistons, or better said, the connecting rods and the bottom of the piston is again this nylon glass fiber reinforced. Of course, this is an oilless system. It's probably not going to be seeing that many hours. It's definitely not generating any kind of pressure inside the system, since it's basically going out at atmospheric pressure, so it isn't building up, 3, 4, 5 bars of pressure. So I guess in the short term this should be good to go. I guess there's 3 years of warranty on the plasma cutter, so even though it's a bit cheap going with plastic casement for the compressor and certainly the connecting rods and pistons, I guess it's par for the course for this price range. And seeing that it's a dual-sided or 2-cylinder compressor, it should give you sufficient airflow for plasma cutting at the maximum 40 amps that this is capable of. So just going on here, nothing too special again about the compressor here. We have our basic ball bearings here that have just been sort of squished out to retain them. Not much maintenance to be done on the compressor side. So now that we've seen the insides of this machine, there's just one test left to do. We're going to measure the volume of this running just its internal fans, and then also running the internal compressor. So let's get on to that. So the numbers we got off this machine seem fairly reasonable, especially for the built-in compressor. You're no worse off using your shop compressor while plasma cutting. All in all, it looks like a fairly sturdy and solid machine. I do like the way the electronic situation has been handled inside. The 2 things that could be improved was probably replacing the fans that are quite loud and probably won't hold up to too much dust and grime getting into the machine, and maybe an upgrade of the two output wires connecting the circuit board to the outputs here. But all in all, another great machine from the Parkside Performance line. If you like this video, please like and subscribe. That really helps get new videos out. There should be a part 2 somewhere in the future where I'm going to reverse engineer the circuit board, so any of you that are interested in that electrical side of things, tune in for that. So thanks again for watching, and see you next time. Bye bye.